Welcome to Sine and Cosine, the functions, part 6. In this video, we're going to look at shifted sine and cosine curves with more than one transformation. If we were to assume that the graph given here is a cosine curve, and I say that because its maximum is at 0, we could draw this horizontal line here that I have sketched very quickly at what appears to be the equilibrium, and that is at approximately 1. So the equilibrium is at 1, which means the graph has been shifted up 1 unit. The next thing we can look at is how high and low the function goes, and it appears that it ranges from -1 up to 3. That's a distance of 4, so the amplitude is 2. If we look at how far it is from the peak of one point on the graph to the next peak, we can see that the curve's period exists between 0 and pi. And if it's a cosine curve, if we assume this is a cosine, then we can set up our inequality so that when we manipulate it, it goes from 0 to 2 pi. So I will multiply everything by 2, and I get 0 is less than or equal to 2x is less than or equal to 2 pi. That means that the inside of my function will be a 2x, and I have an amplitude, no phase shift, shifted up 1 unit. So that means this function is f of x equals 2, the amplitude, cosine of 2x plus 1. In this next example, we have a little more clarification on the period, where it's defined, how long it is, the amplitude, all that stuff is given to us. So if we know that the period for this is 2 pi over 3, that means that we can set this up as negative pi over 6, the starting point for the period, ending point for the period, equilibrium point in the middle. We don't really need the equilibrium point in the middle, but it's helpful to just kind of label everything so we can see the symmetry. And we know that that one period is of length, an interval of 2 pi over 3 long, but we could also write this as negative pi over 6 to pi over 2. And we can put x in between. And now we need to set the left side equal to 0. So let's go ahead and add pi over 6 to everything. And get a common denominator with the pi over 2 here. That's going to be a 3 over 3. So I'm going to have a 3 pi over 6 plus a 1 pi over 6, which means I'll have a 4 pi over 6 less than or equal to x plus pi over 6, which is to the right of 0. So 0 is less than or equal to x plus pi over 6, which is less than or equal to 4 pi over 6. Now if I want to clear my fractions, if I multiply everything by 6, I will get 0, less than or equal to 6x plus pi, less than or equal to 4 pi. We are almost there. We just need to divide everything by 2. That gives me 0 less than or equal to 3x plus pi over 2 less than or equal to 2 pi. So I now have found the inside of my function, which will be 3x plus pi over 2. I now need to figure out if there's any flipping. So if I look at a standard graph of a sine function, and remember we're assuming that this is sine. If we assume that this is a graph of sine with some sort of transformations, we know that the graph of sine looks something like this, where it's positive in the first two quadrants and then negative in the second two quadrants, as if it's unwinding from the unit circle. So if it's been flipped vertically, so all my positive y's become negative y's, and all my negative y's become positive y's for all these coordinates, that means that we have multiplied the function by a negative number. So we know the amplitude is 2. We know it has been flipped. Vertically. So a negative function. And from all of that information, we should be able to graph this. F of x is equal to amplitude 2 sine of the stuff highlighted in yellow in the middle of the tripartite inequality, 3x plus pi over 2 and the only thing we're missing is the negative sign out front. Because remember, if you flip something vertically, you have to have a negative function on the outside. So we will put a negative out here. So it is a negative 2 sine of 3x plus pi over 2.